Welcome to The Explainer. Today, we're breaking down a really pivotal study on a once promising aortic stent graft. And this one is specifically for all of you advanced surgical trainees out there, facing your exams and looking for that consultant-level edge. Okay, let's just dive right in. This quote from the paper, it really gets to the heart of the problem that the Nellix device was engineered to solve. You see, for years, the big challenge with standard endovascular aneurysm repair, or EVR, has been making sure the fix actually lasts. This paper, coming out of Cambridge University hospitals, looks at a device that promised to solve that exact problem.
So, to tackle this whole durability issue, this new technology called endovascular aneurysm sealing, or EVAS, comes onto the scene. And it wasn't just a small step forward. It was really sold as a revolutionary, paradigm-shifting idea.
So how did it actually work? Well, unlike the traditional methods that just sort of line the aneurysm to keep blood from getting in, the core idea here was totally different. It was about actively filling and sealing the entire aneurysm sac from the inside using these special polymer-filled bags. The goal was to completely eliminate any space where leaks could possibly form. Now, this is what's so fascinating, and it's a key point. The philosophy was completely different. Standard EVAR, as you know, needs a good, healthy bit of aorta, the neck, to grab onto. Nellix, on the other hand, was designed for something called sac anchorage. It literally used the aneurysm sac itself for fixation. In theory, this would just obliterate the sac and prevent any and all types of endoleak. And you know what? At first, the data looked absolutely fantastic. Early papers from big registries were reporting amazing procedural success, great one-year survival, and, this is the big one, excellent freedom from endoleak. It honestly looked like this was the game changer everyone had been hoping for. But, and there's always a but, isn't there? As Cambridge, which was a high-volume UK center and a really early adopter of this technology, as they got more and more experience, a pretty worrying pattern started to show up. The team began noticing a failure rate that was much higher than expected, and that's what prompted them to do a full, deep dive review of every single patient they treated. And this is the study we're digging into. Now, it's really important to get this for your exams. This was not some clean, perfect, randomized, controlled trial. Nope. This was a single-center retrospective review of all 161 patients they treated. And that's what gives us this crucial, unfiltered, real-world data, with a really solid median follow-up of 4.4 years. So, what did they find? Well, they found a pattern of failure that was way more common and way more severe than anyone could have predicted from all that promising early data. And this right here, this chart just says it all. In the main group of patients, the ones treated for a primary aneurysm, freedom from graft failure at 4 years was only 42%. Let that sink in. That means after just 4 years, almost 60% of the grafts had failed. I mean, that is a staggeringly, unacceptably high number. And if that wasn't bad enough, look at this. The rate of secondary sac rupture, that's the aneurysm bursting after it was supposed to have been fixed. This is the nightmare scenario, right? At a rate of 2.4 per 100 person years, this was a truly terrifying finding for a device that was designed to prevent that exact event. So here's the kicker, the really crucial point. These failures weren't happening right out of the gate. Look at the timeline. The vast majority of them happened after the 2-year mark. This is the key message. It completely explains why all those initial 1-year results looked so great, and it underscores why long-term, multi-year surveillance is absolutely non-negotiably critical when we're evaluating new devices. The immediate question, then, was obvious. Why? What was the underlying mechanism? Why was this supposedly innovative device having such catastrophic failures? And why were they happening late? Well, the study identified this predictable and frankly devastating sequence of events. It all started with something called caudal migration. The whole device just started slipping downwards. This then led to the endobags separating from each other, which allowed the aneurysm sac to repressurize with blood. And what's really ominous is that this often happened without a classic endoleak that you could see on a scan, making it incredibly hard to catch before it was too late.
And this single sentence from the authors just nails it. It summarizes the fundamental design flaw perfectly. Relying on the aneurysm sac itself for fixation, that idea of sac anchorage, it just wasn't a durable long-term solution. Why? Because the sac itself is not a stable structure to anchor anything to.
So, the clinical impact of all this? It was immediate and it was decisive. The very center that had been an early adopter and a high-volume user of the technology, they just stopped using it routinely, pulled the plug, even for patients who seemed to have the perfect anatomy for it. Okay, let's switch gears. Now you're in the hot seat. It's your FRCS Viva. How do you take all of this information and boil it down into a concise, sharp, consultant-level answer in that high-pressure room?
Let's imagine the examiner leans forward and asks you that exact question. You need a structured, logical response that hits all the key points without rambling. So, here's how you can frame it.
A really crisp answer should hit these 4 areas. First, the background. Tell them it was a retrospective review sparked by a high rate of midterm failures with the Nellix system at a major center. Second, the methods. Mention it was 16 patients with a solid median follow-up of 4.4 years. Third, the key results. Hit them with the big numbers. That unexceptionably high graft failure rate with only 42% freedom from failure at 4 years, and make sure you mention that most failures happened after the 2-year mark. And finally, the impact. The failure mechanism was caudal migration, proving that sac anchorage is not a durable concept, and this is the critical lesson. It highlights the absolute necessity for robust long-term data for any new device. And really, that's the bottom line. The Nellix story gives you the perfect way to wrap up an exam answer. Your take-home message is this. The device, while it was innovative, had unacceptably high midterm failure rates because of caudal migration. This completely challenged the whole concept of sacral anchorage. This case isn't just about one device that failed. It's a fundamental lesson about our professional duty for ongoing vigilance and the absolutely critical importance of robust, long-term post-market surveillance.